Right, hello. Well, in continuation of our discussion of momentum, we're now going to look at 9.2. I'm just going to do a short introduction to 9.2 impact forces. I'm doing this video clip just in case the explanation I gave in class may not be clear to some of you, then you can go back and check. Right, basically I use Fi here to represent the impact force. That is when there is a collision between two objects, there is a contact time between them. The shorter the contact time, as you can see here, if you can use a red pen, the shorter the contact time, the bigger the impact force, and vice versa. If you increase the contact time, then the impact force will be reduced. So basically, this is the basis of this chapter. We're going to look at the impact forces and factors that affect them and how we can actually manipulate the equation. So the first thing to look at is, for a stationary object, we say that the initial velocity u is 0. So even though the object has a mass of m. So if we're going to then put this back in the equation that we already know, so if the object is stationary and suddenly there is a collision, so we have an object m1 and another object m2. So this object is stationary, so u1 will be 0, and then suddenly there is a collision with m2 which is coming, and then it causes it to move, and then it will gain a new velocity v1. So we then say that for that object, the change, the impact force experienced by m1, if I can then say F impact by m1, would then be m1 delta v over delta t, where the delta t there is the time of impact. And in this case, we can then open it up and it will become m1 into v1 minus u1 over delta t, which is the time of impact. And because our u is 0, so this then become m1 v1 over t of impact. So generally speaking, we can then say for a stationary object, the force is equal to mv over t. Okay, and that gives us an expression, so we don't have to even think about it. We say, okay, a stationary initial velocity is 0, the final velocity is going to be something like v, and then we can just, so let's give an example. If m is 10 kg and the final velocity is 10 meters per second, so we can then, and then the impact time is 10 seconds, okay? We can then say the impact force on mass m1 is equal to 10 times 10 divided by 10, and that will be equal to 10 newtons. And that will be our impact force. And that is how we will look at the stationary object. Now, let's look at another scenario when the object is actually moving. So what we say, scenario number 2 is when the object is moving. Okay, so a moving object. So in this case, we can say here is an object m1 moving with u1. Here is an object m2 moving with u2, but suddenly m1 hit m2, and then m2 gained a new velocity v2. So we're just going to say what is going to be the impact force on this mass m2. So in this particular case, we're just going to say the Fi is, again, mass remains unchanged. It's going to be delta V over delta T. And so our mass would then be V minus U over t, and we can then open it up, and then will be mv minus mu again over t. So if the initial velocity, say, was 10 meters per second, and after impact the new velocity was 20 meters per second, so we can then say the impact that will be received, and if everything happens in a time of 5 seconds, we can say the impact received by this particular mass m2 will then be 10 kg into 20 minus 10 over 5. And then if you look at that, that's going to be 10 times 10 over 5, which is 100 divided by 5, and that is 20 newtons. So it's very important to have the right unit. So you can see what has changed in the first case scenario. In the second case is that the impact now has an expression for both v and u. In the case of a stationary object, it will be F equals mv over t. But in the case of a moving object, you have to give consideration to both the velocities, the initial velocity and the final velocity. Okay? In the next video clip, we're going to look at a worked example, and I hope that will help to clarify it a lot better.